problems, it still continues to be used. Many of the systems in banking, in particular, have been in existence for 15, 20 years because they're very large systems, they're very complicated systems, they perform functions that are very important, and it would be expensive to replace them. So typically software will be created, it will be what's called released. In other words, you'll be finished with the first stage of development and you will make it available to the users, put it on the web, put it on the mainframe, whatever kind of software it is. But after that point, changes will be needed over the life cycle. So software life cycle is the term that is typically used to talk about the whole span of time between the time that the problem is defined that the software was supposed to solve and the time when you finally decide, I can't change this software anymore, we need to replace it. And that can be, as I said, a span of many years. Many years. Now, many software engineering textbooks talk about the life cycle of a software package as having phases. The word phase in this context, it's not like the phase of a circuit. It means a period of time. And typically, a period of time that does not overlap with the next phase. This is a little bit of an abstraction. It's an ideal to think about it this way. And we'll talk a little bit more about that in a few minutes. In this course, we prefer to talk about the various activities that are part of a software engineering, part of a software project life cycle. Activities being things that people are doing. So what do we see as being the core activities in software engineering? Well, the first activity that I have listed here, and it pretty much has to be the first in time as well, is problem definition. You need to figure out what the software needs to do, and that needs to be figured out in great detail. Because as you know, you can't be vague when you're writing a program. All of you have written individual programs. You know you have to be very precise about exactly what you want the software to accomplish. And problem definition can be really very difficult because, as Kurt commented, the people who know what the software needs to do are very often the customers, the clients, the people who run the publishing company, the medical doctors who work in the operating rooms. They don't know about software. They don't know necessarily how to translate their needs into a form that you, as a software developer, can take and write programs from. So this is it's a very important and very difficult process. And we'll talk in detail in the next week or two about what some techniques are to attack this activity. The next activity is solution design. So we know what the problem is. How do we build the software? What is the software going to look like? What is the structure of the software going to be? What are the algorithms that we need to use? What are the data structures? What technologies do we need to use? What programming languages? What kind of an architecture? Will this be a client-server system? Should this be a distributed system? All of these decisions fall into the province of solution design. Now this course, CPE311, the title that it is listed under actually in the eKMUTT course catalog is software analysis and design. And we, after discussing the content of the course with Ajahn Pundit, decided that we would broaden the scope. Nevertheless, we will spend a lot of time on the question of solution design because it is a very critical part of the software engineering process. A very large number of the problems that you see when software is finally released can be traced back to this phase here, or to this activity, where the solution design was not adequate. It was not well done. It was not carefully done. It had errors in it. The next activity is solution implementation, and that should be pretty obvious what that means. You've decided what you're going to do. You have decided what tools you're going to use to do it. Okay, go do it. Write the code and make it work. Now that sounds very simple. It actually is a lot more complicated in an environment where it isn't just you that's writing the code, but it's you and you and you and you. And all of your code your code has to communicate with someone else's code. It has to be consistent. It makes the process of implementation much more complex and much more of a problem than it would be if it were a one-person project, where one person is responsible for all the code. In fact, in an industrial environment, it's frequently the case that for a big project, there can be multiple teams. You may not even be in the same country or the same time zone. So I was reading an article from Ericsson, the people who make the cellular phone systems, and they have teams all over the world. And people from all over the world have to collaborate as part of the process of the solution implementation. So although it sounds really simple, just write the code, in practice, it's more complicated than that. Solution validation deals with the question of determining whether the solution that we have designed here and that we are implementing here, whether it actually solves the problem correctly, or whether it has defects and faults. Solution validation includes testing. It includes the process of both testing individual modules or functional components and testing the system as a whole. But as the textbook points out, you can actually validate the solution, and you should validate the solution at a much earlier stage if you can. So you should be able to validate your design before you write any code at all. And the earlier you can start doing validation, the more successful it's likely to be in terms of identifying problems. There's a very well-known statistic about the cost of fixing a problem when it's discovered at various points in the software lifecycle. And a problem discovered here before you've written any code is much less expensive, and it may not be easier to fix because it may require complete rethinking, really a redesign, but it will nevertheless be less expensive than a problem that's found after you've done the implementation, which in turn would be less expensive than a problem that's found after the next stage, which is solution deployment. Solution deployment relates to all the activities that are involved in taking the software system that you've been building and putting it out for the users to actually use. And what that involves in terms of the detailed activities depends a great deal on what kind of software it is, along the lines that Kurt was discussing earlier. Clearly, the question of deploying a large banking system is a very different kind of activity than releasing a new version of Microsoft Word. Very different. But problems that are found after solution deployment are typically much more expensive to remedy, because at that point you have users who are already depending on your software. So you can't take the software away from them while you're fixing it. I mean, assuming this is like a large information system. You are also having real-world costs if this problem that you let go out into the world causes mistakes. Your bank may be losing millions of baht a day because of, some error in your programming. So it's a very desirable thing to find the problems early.